So guys, in last video we covered quite a few questions, and in today we will be continuing it from there. So if I remember correctly, it was question number 17. So let's move on to our question number 17 that we completed, and now we will solve question number 18. So question number 18 says, which of the following estimators can implement partial fit method? Okay, so it is just theory. You have to understand this. Multinomial NB, that is multinomial naive Bayes and SGD regressor. Okay, here is a small tip. Partial fit method can only be applied if it is an iterative approach. Obviously, this SGD regressor or classifier would work with logistic regressor, but the fact is that logistic regressor directly uses the formula approach to do this, and random forest is just tree based approach. So that's why it will not work. So that's totally fine. And this completes our question number 18. Now question number 19 says, fill in the missing parameter value in the following estimator that can be used to classify the data, and it uses sklearn.svm import svc. So support vector classifier, and svc we have to set the kernel value. So for svc we have two kernel. Either we have RBF, that is radial basis function, and another is linear kernel. So keep that in mind. This is just theory. You don't have to worry too much about it. Okay, so linear and RBF, that's the answer for this. For lasso, it is a regularization technique, and for scale, not for SVC. Okay, now question number 20 says, k neighbors classifier with low values of n neighbors produces complex decision boundary. K neighbors with low value of n neighbors produces smooth decision boundary. In k neighbors classifier, the scale of feature can impact the decision boundary. None of the above. And which of the following statements are true? So in this one, this might seem counterintuitive that if we have low values of n neighbors, it produces complex decision boundary. But remember what k neighbors actually does. It uses neighbors to identify it. So say if my n is equal to 1 and I try to plot the data like this. Okay. Now in this particular case, if our n is 1, this will be like this, right? All these are complex decision boundary, complex, right? And this our training data will fit very well, but testing data fails, and this will be an overfit. However, if our n is say 1000, that means that even if my data points are very different, far apart, but they will all come under single umbrella because of this n1000. That means it has to consult 1000 neighbors, and in this case our training data will underperform, testing data will also underperform, and this will be an underfit. Okay, and you have to find a balance between that. So that's why if we have low value of n, it will form a complex decision boundary. Neighbor with low value form a smooth decision boundary. That's wrong. This should be high. High means moderate, not this high. Okay, the k neighbors scale of the feature can impact decision boundary. Yes, obviously, because if the feature is very large, that means it has a long distance, and our n is very small for consultation, that this might leave out, right? It is kind of an outlier there. So you have to keep that in mind also while solving. Okay, I hope that you understand what k neighbors does, because I haven't not gone into the algorithm, but yes, this is the base idea. Which of the following options are correct regarding regularization? It is a technique to minimize the adjusted loss function and avoid underfitting. It doesn't minimizes the adjusted loss or avoid underfitting. What it does is, if you have some weight where you are giving more weight to a particular feature, then it tries to reduce it to increase the bias of the model. So it tries to make sure that your weights remain a particular scale, else it might go out of scope and then the model might cause issue. Okay, it determines the rows to be selected as training. That's totally wrong. Revelation don't does that. Elastic net is a combination of L1 plus L2. There is a formula into that. Look into that particular thing and you will understand what I mean. Okay, question number 22 we will see later on. Question number 23, it asks you for a decision tree classifier. You have your data, you have x and y, you have a tree where your max depth is none, min sample split is 2 and minimum sample leaf is 1. And another tree is also there where you have max depth 3, min sample split 20 and min sample leaf 10. Which of the configuration of tree 1 and tree 2, which decision boundary is more likely to overfit the training data? So if you have max depth is equal to 1, that means you are allowing for infinite depth, and we all know in decision tree infinite depth means overfit. So that's why your answer is tree 1, that is A. Okay, next is question number 24, and it says bagging classifier base is KNN, n estimator is 50, max samples is 0.5 and bootstrap is true, n jobs is equal to -1. Now we have to check which of the following statement are correct. Okay, bag CLF will throw an error, it only accepts decision tree classifier as base classifier. No, that's wrong. Bagging classifier can use any model for its use case, and here we are using k-neighbors classifier, so it's totally fine. Each base KNN will be trained on entire data sets. No, that's also wrong, because max samples means amount of samples that will be used for each of the classifiers. So sampling percentage. Okay, max sample 0.5 parameter means each base estimator in the ensemble is trained on 50% of the training sample. That's what I was saying here, right? So this is right. The ensemble will use sequential computation due to n jobs equal to -1. No, since it is n jobs equal to -1, it will use parallel computation. So this is also wrong. So only option is C. Next is, you are using a random forest classifier from sklearn.multiclass classification problem. You want to ensure diversity among trees to avoid overfitting and increase robustness. Which combination of parameter setting would contribute most to achieve this objective? So here diversity means diverse range. Okay, that means different ranges. Okay, and robustness means less bias. Bias means favor. Okay, so you want everyone to give equal opportunity. So setting n estimator is equal to 10, max step to 3, and using criterion is equal to entropy. So here the problem is that your n estimator is a lot and you have very less max step. So if you have a lot of estimator and you have a very less max step and your criterion is entropy, then you will not be able to diversify. So that's wrong. Increasing the value of n estimators, setting max value to be value less than total number of features, setting bootstrap to false. Because of this particular condition fails, because bootstrap will ensure that you have different samples in each of the run. Okay, setting n estimators to high value, that means that number of trees in random forest will be very high. Means there will be a lot of trees in random forest. Using criterion is equal to Gini. Gini basically uses features and max samples to a value less than total number of sample. So here max samples is number of samples required. If it is less, that means it will require very less number of samples, and if it has very less number of samples, that means that it will generalize well as you will have a lot of tree. So this is the right answer. Setting max step to none, min sample split to 2 and minimum sample leave to 1. So max step to none, that means highest number of estimators or depth, and that will lead to overfit, and we don't have to overfit, so that's wrong. Now question number 26 on the lines of decision tree classifier. Which of the most accurate regarding the parameter attribute of this classifier? So here if you see, the max depth parameter ensures that tree is born to have maximum depth, while tree.maxDepth attribute retrieves the depth of actual tree to the build. So keep this two things in mind. Max depth is a parameter. That means that it is part of a decision tree classifier. But once you have your model trained, the decision tree classifier has been trained, then you use the tree instance variable of the decision tree, which will only be available after training, to get the actual max depth, that is total number of depth. And one more thing is that max depth, which is the maximum depth that we want a tree to go, will be less than or equal to tree.maxDepth, because that is the actual depth that it has went, right? Let's quickly look at other options also. Setting minimum sample split to value greater than 2 can prevent tree from splitting on the feature has minimal influence. No, this is wrong, because greater than 2, that means that more samples are there, but it doesn't mean that it has minimal influence than only sample split. Now third option, the criterion entropy parameter means decision tree will split the nodes to maximize information gain. Okay, that's totally fine. Now, while the tree.impurity attributes refers the entropy of read node, so that's totally wrong, because for this to work, you have to also include a 0, because impurity will be for all the thing, right? So we just want to access the root node. Root node will be at the index 0 for the tree instance variable, right? So that's why you have to include 0. And this is not there, so that's why wrong. So obviously till here it is right, and that's the base idea of entropy also, that it will split nodes, maximize the information gain. If the class fit parameter is set to balance, decision tree will always have balanced cluster in leaf nodes. No, that's totally wrong. It will actually use the same sample method that I showed you in my previous video. Go and watch that, you will understand what I mean. Okay, now the next question is question number 27. In the given parameter grid, for grid search CV, the parameter n estimator and learning rate are meant for ADA boost classifier, while others are for decision tree classifier. Which of the following set of parameters most comprehensive in testing the capability of both ADA boost classifier and its base estimator? So your base estimator is actually DTC, that means decision tree classifier. ADA boost is an ensemble method. So it has a particular way in which you will give the parameters to it, and the way is that whenever you have your base estimator, use the pipeline method to give its parameter. So if you have decision tree, so all the parameters of decision tree will be in this particular format, while for your ADA boost itself, the main ensemble model that you are going to use, you have to use the direct parameter. Either you are using it on grid search CV or directly you have to use this particular method, but since we are using grid search CV, we will just be focusing on our parameter grid. And the parameter grid for this one is ADA boost classifier and estimator 50, 100. Here you can see only ADA boost classifier is given, right? So that's wrong. Max depth itna and estimator itna. So these two are for decision tree, right? So for decision tree it will not work. So that's totally wrong. Decision tree classifier criterion, again we have to use underscore underscore. So that's wrong. Base estimator underscore underscore max depth. So this is for decision tree. Base estimator underscore underscore criterion gaining entropy. So again this is for decision tree. And estimators 3050 and learning rate this is for ADA boost. So that's the base idea here, and that's why your answer is D. Okay. Now next question is question number 28, and it says you are working on a data set containing customer purchase data and you want to segment the customers into distinct groups based on your purchasing behavior. Each data point represents the customer and includes feature like total amount spent, number of purchase. Which algorithm is suitable for the scenario? Now here you can see that it is saying groups and segment. Rest all things are not necessary to understand that much, okay? And if it is saying segment and distinct groups, that means that there are no labels as per this particular question, as well as there are groups. And we know that for groups, K-means clustering algorithm is very good because we are kind of clustering only. So that's the basic intuition behind it. Linear regression is a linear model. It doesn't works without your labels. Decision tree, again labels is required. Support vector machines, again label is required. And linear regression support vectors are linear models, where decision tree is tree based approach. Without labels you can't work with it. But K-means clustering is unsupervised learning algorithm. It can work without labels. So keep that in mind. Question number 29, we will come to that in later part. Question number 30, again we will come to that in later part. After that, you are building an MLP classifier for dataset with large number of features. The goal is to predict whether an online user will purchase a product based on their browsing behavior. You are trying to decide appropriate number of neurons in the hidden layer of a neural net. Which of the statement about adjusting the hidden layer sizes parameter is correct? So hidden layer sizes takes a tuple where length of the tuple represents the number of hidden unit, and the value in this particular tuple represents number of neurons in that particular hidden layer. So it is saying that you have to check which statement is right. So increasing number of neurons in hidden layer will always lead to better performance. No, that's wrong. Increasing will actually work the inverse. It will downgrade the performance because of overfit. Too many neurons, always overfit. Unless until regulation is applied, drop cloud is applied. Decreasing the number of neurons in hidden layer reduces the model capacity to capture complex patterns. No, that's wrong. If you have sufficient number of neurons and good data for that, then it will always capture the complex patterns. The whole idea of neural network is to capture the complex pattern. Number of neurons in hidden layer doesn't signify effectively the model performance. No, that's wrong, because if you have large number of neurons, you can see that without any regulation or anything, it will overfit the model. So it is affecting the model performance. Finding the number of neurons is trial and error process and may require experimentation. Yes, that's totally right. Next is you are designing an MLP classifier for image recognition task. A dataset consists of grayscale image of animals. You want to include non-linearity to the neural network architecture. Which of the element of neural network architecture would you adjust to incorporate non-linearity of the model? Number of hidden layers, it doesn't matter, because this is not about the non-linearity. Because if you know, neurons are what? They are perceptrons, right? And perceptron works on what basis? It works on W transpose X value, right? So that's linear. And once we put that into some activation function, then we get a non-linear thing, right? So activation function is very important here. So that's what your answer is also. And number of neurons in input layer doesn't matter. Learning rate, it's more about application. Number of neurons in input layer also about application. that activation is the right answer. Okay. So our next question is question number 33, and here in this, if you see, it says you're working on a data set of customer purchase behavior including attribute, total amount spent, number of items purchased. You decide to use k-means clustering to segment customers into group based on these features. Which of the following code snippet demonstrate k-means clustering process? Okay, and you have been given this particular code. It says based on given code and the nature of data set, what does variable labels represent? So this particular labels it is asking, and here you can see that it is given comment as print cluster labels. So you have to just say the output of the cluster labels what it will be, right? Let's look at the code. So here you have data, you have k-means cluster as 3, then fit your data, and then you are getting labels. So label will be the cluster assignment indicating which group each customer will belong to. So this will be again an array where, say, if this is for cluster 0, this is for cluster 1, this is for 0, this is for 2, and this is for 1, then you will have 0, 1, 0, 2, 1, something like this. And this will give you the coordinates of the cluster for the labels, right? So these will be just the center points coordinates. So that is the thing. But here it is saying labels. So that's why we have B as answer. So total amount spent by each customer, that's totally wrong. The number of items purchased by customer, that's totally wrong because this is our classification problem. Earlier was our regression problem, and centroid of the coordinates of the cluster form. So it is not asking about the cluster center, it is asking about the labels. So that's why centroid coordinates will not be there, right? Now moving on to our next question, which is the last one, which is 34. You are working on a binary classification task using MLP classifier to predict whether a customer will purchase based on their browsing behavior. You are concerned about overfitting due to the complexity of the model. You decide to increase the alpha parameter to control overfitting. The following code snippet shows the application of MLP classifier. By setting alpha parameter to 0.01, how are you affecting the neural network's model behavior? And it is set in MLP classifier constructor itself. So alpha basically means regularization threshold. Okay. So if we are setting 0.01 as our alpha parameter, that means we are introducing regularization. The regulation is based on our loss function, which discourages any complex models to be learned. So in general, if you have a lot of hidden layers and each has a lot of neurons, then your data might overfit because it will learn every pattern which is important for this particular data. However, if you are setting a regularization, you are making sure that you will not allow complex decision boundaries to occur, and that's what here. Increasing model complexity to fit the training data more closely, that's wrong. We are not introducing model complexity, we are trying to reduce that using the alpha. Making the model more sensitive to outliers and noise in data, no, that's wrong. We have to always scale our data and perform outlier detection and removal for this to work. Adjusting learning rate to control the convergence of the speed. So alpha parameter is for regression, it's not for learning rate, so that's totally wrong. Now let's check what actually our alpha parameters indicate. So alpha parameter in MLP classifier Scikit-learn. So we can see that here the alpha parameter is a regularization term that helps prevent overfitting by penalizing large weights. It adds penalty to the loss function, which encourages the model to keep weights small and thus simpler, right? So there are many ways to set it. In this alpha 0.01 sets the regression strength to 0.01. You can experiment with different values of alpha to find best balance between underfitting and overfitting for your specific use case. So that's it. Now, once we have completed all the basic and easy questions, now let's see the left out questions. Okay.